Introduction to truth trees. So this is chapter 2 of Jeffrey's text. And I just wanted to go through a couple of examples and show you how I do them. You don't have to do them exactly this way. I just want to start the ball rolling and show you the way that I'm doing it, and then as I show examples in the future, you'll know how to interpret those. So let's see. Introduction to truth trees. So for a basic truth tree, let's look at hypothetical syllogism. P only if Q, Q only if R, therefore P only if R. And we can also use the turnstile here for the therefore part. Okay. And if we compare this, we'll see that this is like on page 26, example D here. This example here, D. It has the same structure. A only if B, B only if C, therefore A only if C. Okay, so get used to, not being too attached to one variable or another, and think more about the structure, okay? And so I'm going to use a table here. That's just the way I do it. You can do it however you want. Just make sure that you're being consistent with what Jeffrey wants you to be doing. All right, so now we have P only if Q, Q only if R, and then for the conclusion now, so when we're testing an argument for validity, we want to negate the conclusion, and I'll explain why we're negating the conclusion in the next video, that I do. But for right now, if we're just testing an argument, you're going to follow the procedure, list the premises, and list the negation of the conclusion. So P only if R. Okay, and we're going to negate that. We're going to put the negation out front. Okay, and then we're going to follow the rules of inference, and I think those are just below here. And so we want to, make reference to this table here, and we're going to use this rule right here in this box, and the one right below it. Okay, so we're just going to use these two rules. Okay, so let's see how that works out. So I'm going to give myself a little bit more room. So it is good to start with this negated conditional, because it turns into a stack like this. See the circle over the negated triangle? So you want to stack things as much as possible. That'll help your tree from not getting super wide, all right? And avoid repetitious entries. Okay, so the negation of a conditional is that the antecedent is true, but the consequent is false. Okay, and then once we've used the rule on this premise, we're going to mark it. Jeffrey says to mark it with a check mark. I use percent signs like check marks. Okay, so percent signs are check marks. Okay. And then we have the other rule, which takes the conditional and makes it into two columns not circle or triangle. And this is basically the rule of implication, if you're familiar with the rules of inference, traditional rules of inference. These, of course, are rules of inference as well. But Jeffrey is just not using all the names that we normally associate with them and everything. But sometimes I will do that, and I'll just kind of throw that in. Okay, so let's do the first one. So we're going to do, let me give myself some room here. So we're going to do P, we're going to be actually negated P, not P, or Q. Okay. And we see, oh, and then I wanted to, just to kind of follow along with Jeffrey, I'll draw some branches here. Okay. And then, whoops. And then here we see that we have in this left-hand path, we have P and not P. So that allows us to mark this path with an X. We close it out. Okay. And now we're going to go over here and insert to the right and give us a little bit more space again. And since I've done the rule on P only if Q, I'm going to mark that with a check mark or a percent sign. And then we're going to do the same rule on the second premise. And I'm going to put this down here. And so we're going to get not Q or R. And we can, oops, we can draw there. And so we have something that looks like this. Okay, and since we have, and let's mark this. Let's mark that with a check. Okay. Then we're going to get this to close because we have R and not R in the path. And we have Q and not Q in this path. So that also closes. All right. And then we can say that the argument is valid. So if we're testing an argument, we're going to list the premises and the negation of the conclusion up at the top. We're going to follow the rules. And if we're able to close all paths, then it's valid. If there's an open path, then it is invalid. So maybe I should do an example of an open path. So we've talked about denying the antecedent. So that goes P. So that looks like that. P only if Q, not P, therefore not Q. And this is a common fallacy that we fall into. Okay, and maybe I should take this down here. Okay, so I'm going to list here the premises, and then the negation of the conclusion. And when we have negations out front of a statement, well, with a single variable, you can just have negative, negative. You know, you can have negation of a negation without any parentheses, and that works out. There's some discussion of that in Jeffrey. Okay, so we have the setup. Then we're going to apply the rules. The first rule that we should probably apply is the double negation rule. So a double negation just eliminates the negations. So we can mark that. And then we're going to have not P is already down to the bare bones. So we only need to work on the first premise. So that's going to be not P or Q. All right, we'll mark that. We'll check that off. And just to be consistent here, I'll draw in those branches. Okay. And then here we see that we don't get this branch to close. So we don't look at the entries that have been checked off with the percent sign. You don't even need to look at those anymore. They're taken care of because we've applied a rule of inference to them. But we just look for contradictions that are left, and we see that here we're left open. And even this is open. All right, so precisely when P is false and Q is true, the premises are true, but the conclusion is false, and so it doesn't meet the definition of validity. It's an invalid argument. All right. And now, when I do this, I'm not gonna put in these branches. I'll just do this. I'll just have a table, and I'll make it a little more compact. So I'll just do something like this. And that will mean the same thing. So this branch goes up to here, which goes up to here, which goes up like that. This branch goes up and over, and this branch, of course, goes straight up. So I'm just going to do things in this kind of table form, and you'll just have to understand that there's a branching here because we're going into another column. That's where a branch occurs. And you'll see that we get some different patterns that are, you know, maybe not as easy to follow, but after a while it's pretty straightforward. And I just like that for simplicity. And I can use, of course, Microsoft Word here, and you know, it's easy to read, especially when we're doing a Zoom presentation, right? So we could have something like the argument from section 1.3 that gets a little more complicated. Okay, so let me do this. Section 1.3. Is this argument valid? Okay, so we have. So if you're following along and doing what Jeffrey tells you, you should have already worked this out using the methodology of chapter 1, but we can do it also, we can check the validity using chapter 2 truth treaties. So we have A or B as a premise, C or D as a premise, not B and not D as a third premise, and then the conclusion is A and C. And so I've done the premises and then negated the conclusion. And now we're going to follow out the rules of inference and see what happens. Okay, so the best thing to do here is to start with the conjunction, because that's gonna give us more vertical alignment and reduce our duplication of entries. So if you have a conjunction, you just put them vertically in one path. And so this is going to be not B, and not D. All right. I'm going to mark that there. And then we can, we're not really going to get anything more tidy than that. So I'm going to put A or B here. So this is from the first premise. And so I'm going to mark that off. Okay. And let me see, I'm going to clean this up a little bit because we're going to, I'll show you how I do this without drawing the lines. So A or B, and then we need C or D. Okay. So what I'm going to do is I'm going to insert a row, or sorry, a column to the right. So this B hanging out here is still branching back to the not D, but I'm going to insert in here C or D. Okay, so that's from actually let's do this a little more strategically. Let's do not A or not C. This comes from the negation of a conjunction, gives us the disjunction of the negations. So that's De Morgan's law, if you're familiar with that, but just in Jeffrey's sort of schematic form. And so here we're going to get negation of A, and I chose this because I see that this is going to close out quite nicely right there. And then we'll do negation of C. And so that's taken care of. And we can close this out. So that eliminates some entry, I think. But at least that's what came to mind when I was just looking at it. Okay, and then and now we're going to do the second premise, C or D, and I need to insert a column here. So I'm going to do and I should have already, actually, when I first entered this here, we should have closed that out. So that's closing immediately as well. Okay, so that's closed out. This is closing out. We just have this not C path that goes not C, A, not D, not B, but we have C or D here. All right. So this is where I'm going to insert, and then I'm going to go C, D. You know, that's what the branching of the tree means. It means we have a disjunction. And so we're just mapping this out in tree form. We see that C and not C, those close out. And then D, not C, A, not D, close. All right. And so we see that this argument is valid because all of the paths close. So if they close, following this procedure, you get valid. If they don't close, then it's invalid. And even if you just have one, path through the tree that's open, then it's invalid. One path, one or more, at least one open, then it's invalid. If all of them close, then it's valid. But it's only valid if all of them close. If even one of them doesn't close, then it's invalid, because that open path actually defines a counterexample, as was being discussed in chapter 1. Okay,